Hello everyone. In my today's session, I will be discussing few tricks to solve numericals on work done. In my previous video, I have already shared the tricks to know and understand which formula we need to use by solving the numericals on work done. Okay, so let's get started. The first question, 3 moles of an ideal gas are expanded isothermally from a volume of 300 centimeter cube to 2.5 liter at 300 Kelvin against a pressure of 1.9 atmosphere. Calculate the work done in liter atmosphere and joules. Now, first of all, we need to write down the given data. We have been given the total number of moles, that is N, is equal to 3 moles. Initial volume, that is V1, is equal to 300 centimeter cube. Now, 300 centimeter cube can be converted into liters. So, this is 0.3 liters, or you can also write it down as 0.3 dm cube. Next is final volume, V2, we have is 2.5 liters. The reason to convert this 300 centimeter cube to 0.3 is both the volume should be in liters. Okay. Next is external pressure. We have P external is equal to 1.9 atm. Okay. And then the temperature we have is 300 Kelvin. Let's proceed to the solution. The formula is W is equal to minus P external delta V, which can also be written as W is equal to minus P external V2 minus V1. W is equal to minus P external, which is 1.9. V2 is 2.5 minus 0.3. So we get the answer minus 4.18 liter atmosphere. Okay, so this is the answer for work done in liter atmosphere. Remember, in the question, it is clearly mentioned that gas is expanded. So if gas is expanding, definitely the work done will be negative. This I have already explained in my previous video. So kindly refer the video. Now let us proceed ahead with the next question. That is, we need to find out work done in joules. Now we know that 1 liter atmosphere is equal to 101.3 joules. Okay, so there minus 423.4 joules. So this is the answer in joules. Okay, so this is how we are going to solve the question on work done. Now let us proceed ahead with the next type of question. The second question, 16 gram of oxygen expand isothermally and reversibly at 300 Kelvin till its volume is doubled. Calculate the work done. Now the given data is weight of oxygen. We have been given weight of oxygen, that is this is equal to 16 gram. Now from this 16 gram, I can simply calculate a number of moles. Okay, but first we need to convert the 16 grams into kg. So this can be written as 16 into 10 to the power minus 3 kg. Clear? The next thing is we need to write down now the molecular weight of oxygen. So molecular weight of oxygen 32 gram. Okay. Next thing is we can simply convert this 32 grams into kg. So this thing will be 32 into 10 to the power minus 3 kg. And then N, that is number of moles, you can calculate it as mass upon molecular mass. That is nothing but a weight of the oxygen is 16 into 10 to the power minus 3 kg upon molecular mass or a molecular weight. I can write it down as 32 into 10 to the power minus 3. Now both of these will get cancelled. 16 ones are 16 twos are, and then finally we will be getting number of moles as 0.5 mole. We have been given is a gas constant, that is 8.314 joule per Kelvin per mole. Next is temperature we have been given is 300 Kelvin. Now given that volume is doubled. If the volume is doubled, that means we can write down that final volume is equal to double of initial volume or twice of initial volume. So I can write down this as V2 upon V1 is equal to 2. Now, since in the question we have been given isothermally and reversibly, that means the work done will be, in this case, W max, that is maximum work done. And the formula which we will be using is minus 2.303 nRT log to the base 10 V2 upon V1. Simply substitute the values. W max is equal to minus 2.303, N is 5, R 8.314, temperature is 300 Kelvin, and then log to the base 10, V2 we have is, V2 upon V1 we have is 2. You can simply refer this part, okay? It is log to the base 10. Now we need to find out the log of 2, okay? 2, we will consider 2 as a 2.00. Okay. Now, the very first thing is you need to find out the characteristics. Now, for characteristic, you simply need to use a n minus 1 formula. Okay. N is the number of digit before the decimal point. Now, we have only one digit. I'm talking about a digit, not the value. So, we have only one digit. So, simply I will subtract 1 minus 1, which is equal to 0. Okay, so the characteristic over here will be 0. Now let us look into the Mentisa. Now first we are going to take two digits, okay, these two digits, that is 20. So in row 20, okay, and then you are going to look the column number 0. Okay, so this is the column number 0, and then the next digit is 0. So we do not have any mean difference over here for 0. So just ignore that part. Now in 20 we have the value 3010. So simply add this to the characteristic. Okay, so you will be getting 0.3010. Log of 2 is 0.3010. Okay, 0.303 into 5 into 8.314, 300 into log to the base 10 is 0.3010. Yes, we can do this calculation using log table. So quickly we will have a look on the logs. The first log of 2.303, then log of 0.5, log of 8.314, log of 300, log of 0.3010. And then we need to add everything since multiplication is given. I hope everyone knows the different properties of our log. Okay, wherever you have multiplication, you are going to carry out the addition, okay, for log. So log of 2.303, first of all, you need to find out the characteristic. The characteristic over here, it will be 0 because only one digit is present. Okay, so this thing will be 0 point, and then 23, 0, and then 3. In 23 row, you will check in 0 column and then 3 column for mean difference. So 2303, it is 23, and then the third column. So you need to add 3617 to 6. You will be getting it as a 3623. Okay, so my answer will be 3623. So likewise, you can calculate the log for all the values. Okay, now remember, if it is a 0.5, then you need to put bar 1, and then you will check in 50th row in column 0. So 50th row column 0, it will be 6990. Same way for this thing will be 0.9198. For 300, it will be 2.4771, and for 0.3010, it will be bar 1.4786. And then now after carrying out the addition, you will be getting the answer as 2.9368. Now whatever answer you get, simply find out the anti-log of it. So now we will be referring anti-log table. So anti-log of 2.9368. Now for anti-log, you are going to look into the digits after the decimal point. So I will be checking it in 93 row, 6th column and 8th column of mean difference. So now we will be adding 8630 and 16. So I will be getting 8646. 9368, we got the value 8646. Now this for 2, you need to simply use the formula n plus 1. Okay, that means this value 2 plus 1 is equal to 3. So after the third digit, I will be putting the decimal point. So my answer will be 864.6. So I'll write down the answer. W max is equal to minus 864.6 joules. So this is my final answer. So understood how to use the log and anti-log table to carry out any calculation. No matter which chapter you are studying, which topic you are studying, you can use the log calculation wherever required. Okay. Now let us move ahead with the next question. 300 millimole of an ideal gas occupies 13 liter at 300 Kelvin. Calculate the work done when the gas expands into vacuum until its volume has increased by 3.8 liter. Now, if you carefully read the question, I can see the word vacuum. Okay. Whenever you come across the word vacuum, and if the question is asked on W, so the answer will be 0. Okay. So these entire, now just simply looking at the question, do not panic by looking at all the values. All these values, they are simply given to confuse you. Okay. Simply look at the word vacuum. So W is equal to 0. Now, why W is equal to 0? Because W is equal to minus P external delta V. And in case of vacuum, the external pressure is 0. So this entire equation will become 0. So this is everything we studied today about work done and the different formulas which you can use to solve the numericals based on work done. For more interesting videos, keep watching my Instagram page and YouTube channel, and do not forget to subscribe and share my channel. So let's keep solving the mystery of chemistry in easier way. Thank you.